here. I found that if I record locally, I can actually upload faster, so that's kind of nice. All right, let me hit F5 on that. Boom. Okay. Hopefully audio and video's up and you all can see the slides. So welcome back to Steel Design. It has been a week for the record books, that's for sure. Hopefully, we were talking a little bit before class. Hopefully it didn't last too long without power, and I hope that the majority of you do have it. I just went through the roster right before class started. It looks like most people are here, which is good. I did have 2 names that were absent, so I'll contact them after class just to make sure that they're good for the exam on Wednesday. Okay, thank you for that. Let me write that down. I appreciate that. Okay. All right. Thank you. I appreciate that. Okay. I'm writing those notes down. Bear with me. No, I can appreciate that. I definitely can. Which is why, I'll admit we've lost a week of instruction, and I was tempted to just not have the exam review and go straight to the exam, but I thought that wouldn't be right, given the fact that we had been planning on it. And 2, I figured that, even if everybody's fine today, because we lost a week, that we probably could use the time to just sort of like recoup and get back into the swing of things. So I think that the exam review today is probably a good idea just for those for that respect. Just so everybody is aware, I'm going to count everybody present today, just cause I don't think today is worth the the headache on the and I see the chat on that. Thank you for that. I don't think it's worth it to start counting people absent on a day like today when there still could be people without power. So regardless of whether they're here or not, for today, I'm just going to count everybody present, just to make that simple. For the homework, there hasn't been much progress made on the homework, just because, again, just trying to get things caught up. Homework 2.8 is still due today, though. Let me see something real quick. I think I had checked it right before class started, and it looks like, yeah, everybody has submitted it. So I'll go ahead and turn the solution on right after class so that you have that for review. But we'll try and get those graded as soon as possible. I know that there's a little bit of a backlog there, but I'll talk to the TA and see what we can do. I do still want to have the exam today at I don't have the exam review today. I don't want to have the exam Wednesday. Sorry about the slip there. I want to have the exam review today, and so let's get into the logistics. So what we're going to talk about is first the logistics, and then the content of the exam, and then open it up for questions, and whatever you want to ask, the floor will be yours. Let's start off with the logistics. So we're going to deliver the exam on Blackboard. The exam's going to open at 11 and close at noon. If you had me last semester for structural analysis, and I know a lot of you did, it's the same thing. There's no difference in terms of how I'm going to implement the exams. If you didn't have me for structural analysis last semester, you probably had me for concrete design in the spring. And I'm doing the same thing that I did in there too, which is that whenever you log on to Blackboard, there will be 2 forms that show up. There will be the exam form, which is the actual timed exam, and then there will be an upload page for you to upload your scanned PDF of your computations. So there'll be the timed portion and the upload form. The upload form is going to close at 1 p.m. so that you're not feeling rushed to get the calculations to me, but I do need them to begin the grading process. So at 11 a.m., both forms will open. You just need to complete the time portion by noon and the upload your calcs by 1 p.m. Now, the exam is designed to be 50 minutes long. I'm giving you an hour just to handle any potential logistical issues there. But I have always used the same process in here that I've done in the past, the whole rule of 3 thing. If I can do the exam in 20 minutes, you should be able to do it in an hour. And I still use that process here. I've been teaching I've been teaching this class for quite a long time, and I've never really had students complain too intensively about the time on these exams. So I don't think that'll happen here either. In terms of the operation, so the exam, the timed portion will be a forced completion exam. So once you start it, you got to finish it in one sitting. It will be a timed exam with auto submit. So it'll save and submit your results after 60 minutes if you haven't done so. And I kind of like that actually for your benefit, because that way you know that your results that are in the form are saved. I make sure that the questions appear all at once, as opposed to one at a time. That way you can review your responses before submitting. What about the approved materials? This is an online exam, so you can use all the notes. You can use the manual. Let me just say this: you need the manual. You got to have the manual for the exam, either the hard copy, or if somebody went with a digital edition, you need the manual. You can use any resource on Blackboard. Lecture notes, you can go to the recordings, you can pull up the homework solutions, the OneNote. You can use whatever you want. You just cannot use another person. And so that means another individual in the class, some forum on Chegg or something. You all know the deal. But again, I don't think that this exam is going to be the most challenging thing in the world. I mean, if you've been paying attention to what we've been doing here, this stuff really isn't all that difficult. There are some questions I can ask you that'll make you think, but I don't think it's outside the realm of possibility. The exam format will be very similar to the exams I've given in the past. There'll be 4 to 5 short answer, sort of conceptual questions. And so one of the things I'll say about that is don't write, a dissertation on a problem that's worth 2 points. Just answer the question and move on. So you really shouldn't be responding with more than 1 or 2 sentences. And there'll be 2 to 3 computational problems that you actually have to do some math on. And that'll be the bulk of the exam in terms of the grade. Do me a favor and type out an answer for every question, even the computational ones, because it does help out with the grading. And don't just answer the question on your scratch work. Again, type it out. It does help. Let's talk about the topics on the exam. And so you can fit all the topics that are on this exam on a single page. What do we have on exam 1? We're going to cover the fundamentals, which is make sure you generally know what the process of structural engineering is. We talked about that during the first lecture, and that you know the difference between ASD and LRFD. And then for the star of the show, which is tension members, make sure that you can analyze a tension member according to the following limit states. So that's gross section yielding, net section fracture, block shear rupture, and slenderness limits, and that you can design economical shapes for prescribed loadings. And when I say most economical, I mean the lightest weight. And so that is everything that we've talked about up until this point in a very concise slide. As for some references for you, and I always try and do this on the exam review slides, is I try and put everything in one presentation so that you don't have to start digging in multiple slides. They're there if you want, but I really want to try and make it easy on you. So first off, LRFD, I want you to understand the process. So you've got factored loads and factored resistances. So how does that work? You take a nominal resistance, you factor it by a phi value, you get a factored resistance, and then you take loads and you combine them in those statistically calibrated load combos to get a factored load. And so as long as the factored resistances are larger than the factored loads, the structure is safe. What about those load combos? Here's the load combos. So there are 7 load combos. Predominantly, the first and the second one are the ones that end up being the star of the show, but specific or generally, I guess, you should be going through all of those and finding the largest one that governs. So generally, that's what you do, but specifically, usually the first 2 end up governing because dead load and live loads tend to be on all members. Now, again, I'm talking about sort of for the purposes of our exam on Wednesday. More than likely, those 2 are going to be the ones that govern. In real life, you have to go through them all, but it goes down to context, and software can help you out with some of that. What about those ice loads? That's a good question. there are provisions for stuff like that in the spec. We're not going to consider it for the exam, but it is covered. Maybe we should start talking about it. It's fun. I went outside my house after the power got restored, and I was looking at our central air unit, the box, the fan with the box. There were 3 inches of ice, just solid 3 inches. It was crazy. I couldn't believe it. I mean, like, I've seen snow accumulate, but it was just solid ice. Wow. Okay, let's talk about tension member limit states. So we got gross section yielding and net section fracture. So we all know the formulas here. These are our fundamentals. Now, these are 2 of the limit states. There's a third one called block shear, which we add later. So in these limit state evaluations, you need some properties. So the first thing you need are the properties for steel based on its grade. So that means Fy and Fu. You can find that it starts on table 2-4 on page 2-48. That's for rolled shapes, and for plates, it's the following table. Most of the values are the same in both tables, so it's not like it's terribly necessary, but sometimes you can find some grades that are unique to just one table. That's why I want to reference both. So if you want to bookmark location in the manual, that would be a place to bookmark. Remember, there are ranges in this table sometimes. So like the A36. So for example, so like the A36 has 36, and then the FU is a range between 58 and 80. Whenever there's a range, you always use the minimum because that's the more conservative value. All right, what about our complete expression for net area? So for bolted connections, the net area is found by taking the gross area and subtracting all of the relevant bolt holes. So that's the diameter of the hole times the thickness. And the diameter of the hole is the diameter of the bolt plus 1/8 of an inch. And remember, we add 1/8 of an inch because we're really adding a 1/16 twice. 1/16 for damaged material, 1/16 for erection tolerance. And then we also add any necessary stagger factors. So the stagger factor is S squared over 4G times the thickness. And so S is the longitudinal spacing along the direction of the load. G is the transverse spacing perpendicular to the applied load. That's for bolted connections. For welded connections, if you have fillet welds, you're not removing any material, so the net area equals the gross area. Okay. Okay. What about shear lag factors? Shear lag factors are found in Chapter D, specifically Table D3.1 on page 16.1-30. That's another bookmark one if you haven't already done so. Also, keep in mind that for a given connection scenario, it's possible that multiple cases could apply. So, for instance, if you had a W shape connected via the flanges, we applied case 2 and case 7. We've had instances with angles where you could apply case 2 and case 8. So just make sure that you're reading the table, and keep in mind that these are empirical. So just follow the math, go off the table, report the appropriate value. For design, we design based off of gross section yielding and net section fracture. So we determine our factored load, and then we compute our 2 design parameters. That's the radius of gyration and then the gross area. In the gross area, we just take gross section yielding and net section fracture. We make an assumption that the effective net area is 75% of the gross area. And so that is a just blanket assumption that we're making in order to get to a trial shape. We then have to take that trial shape and assess it in order to ensure that that assumption was valid. Because it's possible that we make some assumptions to get to a trial shape, and then that trial shape doesn't work, in which case we would need to go to the next shape and iterate. So we have to analyze that section in order to verify its performance. And ultimately what we want to do is summarize those results and compute the efficiency. And the efficiency tells us whether or not our section is, not only whether or not it's a safe design, but whether it's an efficient design. Because rule of thumb states that if your efficiency is 90% or greater, that not only does it work as long as that efficiency is less than 100%, not only does it work, but that it's an economical design. Okay. Now for block shear, that's sort of the new one. That's the last thing that we covered. So there's a big old expression that you plug into, and it looks nasty, but really all the parameters that go into it are fairly familiar if you understand everything else. You understand gross and net area, so you should be able to figure out gross and net area in shear and gross and net area in tension. Beyond that, it's really not all that challenging. You just have to, don't forget to apply your resistance factor, because that gray box will compute a nominal resistance. You need to take that nominal resistance and multiply it by 0.75 to get a factored resistance. And so just make sure that you're, if you're comparing, let's say, to a factored load, that you're comparing apples to apples. So the load has to be factored, the resistance has to be factored as well. And then in the expression, I guess the other point is UBS, it'll always be 1. One question I always get during exam reviews, I'm just going to handle it now. Dr. Michelson, do we have to handle block shear for a staggered bolt path? No, you don't. I'm not going to worry about that, okay? I don't really even worry about that during normal conditions. But is it any more difficult than handling it for a straight path? No. All you have to do is anytime you have a tension path and you have a stagger, just add a stagger factor. But I'm not going to worry about that, so don't worry about that. If there's a block shear problem, it will not have stagger, so don't worry about that. UBS equals 1 in most cases, and again, don't forget your phi value. Now, you're going to have to compute 4 areas, a gross area in shear, net area in shear, gross area in tension, net area in tension. You actually don't use the gross area in tension in this formula, but you still have to compute it, because in order to get the net area in tension, you have to compute the gross area first. So you'll compute all 4, you just won't use all of them in the expression. Okay, that is it for what I've got here. Let me go ahead and hit escape on this. I have here a notepad if anybody wants to go through things. If you want me to pull something up, I'm going to stop talking. Floor is yours. Any questions you've got, I will do my best to address them.
So, on the exam, we'll be allowed to submit our equation sheets or what we do our work on separately, or do we have to submit on the exam window?
No, there's 2 forms. There's the timed exam, and then there's the submission form, right? So let me see if I can kind of show you. I'll do my best to show you.
I'm just you don't really need to. I just need to confirm that there is 2 separate submission windows, or do we add to our comment section in the...
No, you don't add it to the comment section. You submit it as a separate document.
Okay. Well, can you just show us the problem with a staggered shear? Like, we have to determine what is the path of bolt holes, because
for block shear,
I believe so. Yeah. No, like what was he?
I mean, I'm more than welcome to, but I'm telling you that I'm not putting that on the exam. Yeah, okay. What Harrison said would be fine. So like, where'd my pen go? There's my pen. So, like, if you had a member, maybe your block shear path looks like this. But again, I'm really trying to emphasize this. I'm not putting that on the exam.
All right, that because admittedly the pathways are like slightly confusing.
That's why I'm not doing it. That's what I'm saying. I don't want to spend time in our exam review talking about something I'm not putting on the exam. Because I want it to be valuable for you. So again, floor is yours. I feel like I'm going to get off easy today. Y'all got to make me work for a living.
Sorry. Well, one moment here.
Is there anything you typically see students see on exams students do that we should avoid? That's a good question. And I'm going to try and answer that question without revealing too much. That's a very, very good question. Okay, so to be clear, the question was, is there anything that you typically see on exams that students do that we should avoid? A few things. Okay, number one, on the conceptual side, I have seen sometimes students write these, paragraphs and paragraphs for a problem that's worth 3 points. Like, use your time wisely is what I would say. If you have 4 problems on an exam and each problem is worth 25 points, then you should be spending around 25% of your time on each problem. If you have a 50-minute exam and a problem's worth 3 points, don't spend 10 minutes writing a paragraph. You're just making the rest of the exam feel more rushed. All right, that would be the first thing. The other thing I would say is something you should avoid is I'm gonna try and say this appropriately. I am going to probably come up with something that challenges you, but is not unfair. I really don't like to come up with exams that are unfair, but I do want to test your abilities. Okay, read the problem and answer the problem. And what I mean by that is sometimes I'll find a student who reads a problem and then just starts doing what they did in the homework assignment because that's what they did on the homework, thinking that, well, I'm just going to do this because that's what Dr. Michelson wants us to do. No, I want you to answer the question, okay? So I've had instances sometimes where students do pages and pages of work because that's what we did on the homework assignment, when if you actually read the question, all you had to do was take a couple numbers here, do this, and boom, it was done. So, read the problem and answer the problem, I think would be one thing to do. I'm trying to think if there's really a third thing that I can think of, but I'm having a hard time doing that. Just time management and actually addressing the problems on the exam instead of just regurgitating homeworks and in-class lecture problems. I'm not saying that the homework is going, or the exam is going to be completely alien from what we've done on the homework and during lectures. That's not the case. But I'm going to address what Zach said, because that's a good point too. Yeah, I'm not saying it's not going to be completely alien. I mean, there's going to be a lot of common material, but don't just regurgitate homework problems and lecture problems. Like, actually address what's in the exam. And Zach said, remember, the connection length is not from bolt to edge, but instead center to center of bolts. That is true. That is true. Oh, another thing, when I say read the question, another thing that can happen, this is a good one, and Zach's comment sort of sparked an interest, or something in my head. As you have noticed, if I were to give you a full-blown problem that said, okay, I want you to design this member for gross section yielding, net section fracture, slenderness, and then check block shear afterwards, like that one problem, that's actually kind of a long problem. And as a result, if I gave you 3 problems like that, it actually might be a time crunch. And so one of the things I might do is I might give you some values in order to make the problem more doable. Like, here's an example. I might say, analyze this tension member. Oh, by the way, Fy is 46 KSI and Fu is 62 KSI, or I'm making those numbers up. And so I might just give you those values and say, here's Fy and Fu. And what you do is, because it's a homework, because it's like what we've done on the homework or what we've done on the exams, you go and look up Fy and Fu. Like, why'd you look it up? I gave it to you. So sometimes actually just reading the problem, I could save you some time. So yeah. All right, I can't think of anything else, and I want to leave room for other questions. But that was a really good question. And I saw that, yes.
Now, how do you want us to contact you during the exam?
How do you want us to contact? You mean if there's a problem or what? So let me just say this. So if you have a problem, like you can't log on or your internet's out or whatnot, just call me. Call me on my office line. I'll be here. And if there's an issue, just pick up the phone and call me. If you have a question throughout the exam, you can send me an email. That's fine. Or you can send me a chat on Teams. If another thing, if there are any exam-wide clarifications, like if like I have a mistake on the exam, which I'm a human being, it happens. I might post something to the Teams channel and say, "Oh, hey, everybody, check this out," or I might send a class-wide email. So make sure that you have your email handy, I guess I would say, and make sure you have your Teams handy.
Just a quick question here. I don't know if this will occur during the exam, but I don't know. But what happens if we check your steel design manual to confirm something, but the value given serves as a contradiction in a way? Because, like on the material types, for example, we're given certain ranges for the FU and FY strength levels, but if the value is like, say, less than normal, should we email you about it or use the steel design? Or
Wait, hold on, I'm confused. Could you say that again?
I know this is a question that I don't know if will come up.
Well, before, let me say, I think you might be getting a little bit into the weeds a little bit, but I mean, all I can say is, look, if you have a question, like, ask, and if I can answer it, I will. I'm usually pretty diligent about, like, whenever I post an exam, I usually take the exam before I post it. And I usually catch, like errors and stuff like that then. If there's something that's, if you have a question, just, ask. And if there's a clarification, I'll send it. But it don't try and get all like, well, what if this, what if that? Like, just I guess just try and focus on, let's just talk about steel design. And understanding that is what's going to get you through the exam.
All right. So I have one last question here.
Yeah.
We went over in the class about selecting different on the shapes in the steel design manual. There's multiple different versions. So we have to eventually try to get a minimum type version, correct? We have to find a W shape. We have to do the minimum bit requirement on this case. The minimum.
The lightest weight, you mean?
Yeah. And during the exam, will there be any questions that may ask us to select different shapes, or that you go shape? Go ahead.
So whenever we're designing, our goal is always to select the most economical section. I'll never ask you to select the heaviest section, because you could just pick a W14 by 800 and it'll work. I promise you it'll work. It's a running joke in steel design that I promise you the W14 by 800, it will work. So I'm not going to ask you to select like a heavier section. Like if it's design, I'm always going to ask for the most economical one. Okay. Now, on top of that, it is an exam. So in design mode, I told you during the homework assignments, and it'll be the same on the exam, I will probably restrict it in some fashion so that we all arrive at the same answer. In other words, I might say select the lightest W14 shape, or select the lightest channel, or select the lightest equal leg angle, or something like that. So that if you do the math properly, you will only arrive at one answer. Okay? That I will do, because, there's no benefit in creating a confusing and unclear path so that we've got 22 different answers and they could all be right. I don't really want to grade that. And I don't think that makes for a good exam either. Now, a design project, that's a different story. But we're talking about an exam. So I did that on the homework assignments. I did that on the lecture problems. I will do that on the exam as well.
All right, I think I understand.
All right. Will there be multiple versions of the exam? Well, so that shouldn't matter. Just say yes. I guess I should make them now. Why would that matter, Mr. Ball? Are you getting voted off the Among Us? Somebody reported, and you.
What happened here?
Yeah. I mean, why? But in all seriousness, why would that matter? As Mr. Blizzard said. Now look, there's a reason why they do that. And if I have to come out and say it, we might be missing something here. Look, I mean, let me say this, I've been teaching a long time, and this has been my experience. Okay, have I caught students, engaging in academic dishonesty before? Yes, I have. And the way that I've caught them, and I'm just being honest, is you could tell when students have worked together or when they've pulled stuff online just because of the way that their submissions are. Like, for example, I remember it was either last year or the year before. Yeah, it was last year. I caught a student doing that on homework because their homework was actually using specifications like a steel manual from the 70s. A lot of times you'll find online resources for steel design, but they're old because the steel design manual gets updated quite regularly. And so I'm pulling this homework, and the notation, we didn't cover that in class. It's like, where did you come up with that? And it's clear you didn't come up with that from me or from the notes or from what we've been doing in class. You found it on Chegg, and that it was pretty clear, and you could tell. I mean, it's actually not that hard to tell when somebody is collaborating. What Mr. Blizzard said just now is very poignant because I have found that the students who just do the work, just take the test, do the work, even if they have a mistake here and there, do better than the ones who are stressed out and worrying about finding stuff online, using it, and then trying to conceal it, because they end up not concealing it all that well. At least in engineering land, it's kind of easy to find it, easy to discover it. And then if you had just done the exam, it would have been easier. Just do the exam and you'll be fine. All right. So with that, let's get back to steel design. Does anybody have any questions about steel design? We've been here for a while. I haven't had many questions about steel.
So I have a question about the shear lag factor.
There we go. All right, question about shear lag factors.
Okay, if I don't find an X bar on the shape. Do I just ignore case 2 because it requires an X bar?
Wait, hold on. Can you give me an example of what you're talking about so that I can? Because I think you have like a. Now, Mr. Romans asked about guessing there will not be any pipes or rectangular HSS. Actually, I'm going to push back and say there very well might be pipes or rectangular HSS, but I'll say the same thing about that I would say about any other section. Like, it's possible I throw something out there that you haven't seen, but I'm not going to throw you too far into the wilderness that it's totally impossible. So, for example, I might throw a member type that you've never seen before, but then I might say, well, take this value to be whatever, take the net area to be this, or take, I don't know. I might throw some simplifying factor to make it not completely impossible. You know what I mean? Like I might challenge you, but I'm not going to challenge you to the point of impossibility. I don't think that's valuable. So the answer is maybe, and that's as clear as I'm going to be. Now, do you have Mr. Blizzard, did you have an example you came up with?
I'm getting the book open right now, sorry.
Okay. Mr. Mitchell asked a question. Can you clarify when it's necessary to find a special X bar for a connection? Most of the time, you can use the centroid value that's in the manual. So, for instance, if you have a channel connected via the web, you could just use X bar for the channel, and that works. If you have an angle connected by the long leg, you can use X bar. If it's connected by the short leg, you'd have to use Y bar. The only time that I think you would need to use a special one is the W section connected via the flanges. Then you'd have to pull up the equivalent WT. Now, in practice, there might be some others. Like, for example, a W section connected via the web, you would need to determine that centroidal distance, from the from the center of the web to the centroid. But that would involve you doing some math on the side. Let me say this. This is a class on steel design. This is not statics. This is not mechanics and materials or deformable bodies. So I am going to ask you questions that are steel design questions. Now, if I had a W section connected via the web in the real world, I'd say, okay, break out AutoCAD, break out a sheet of paper, compute the centroid. And I mean, you all know how to compute the centroid. You've taken these classes before. But it's a 50-minute exam, and I'm not interested in giving you a test about something in Engineering 213. You pass that class. You wouldn't be here if you didn't. So I don't need to test you on the super hyper specific stuff in stack. That doesn't mean I don't expect you to know some of that or understand some of that stuff. I expect you to understand, forces and moments and, support reactions. No, I feel like a broken record from 312, but I do feel well prepared. Snow and ice and hurricane aside. There's not going to be any ice loads or any hurricane loads or anything like that. You do mention 312, and it may show up on this exam. It will definitely show up on the final, and I'm just going to go ahead and tell you that it'll happen on the final. But I will give you on the final a structure and have you analyze that structure and use those analysis results for design. I'm telling you I'm doing that on the final because of the nature of that topic. Is it possible that I do something like that here? Maybe, but if I did, it wouldn't be anything, remarkably complicated. Again, I'm about challenging you. I'm not about tricking you.
You ended up answering my question when you.
The W section connected via the web.
Yes.
Yeah.
Equivalent WT.
Well, if you had a W section connected via the web, what you would do is split it in half, and you'd have like a channel, and you would compute the centroid of the channel. But that I'm not going to have you all do that. We're not doing that. Because in order to do that, you'd have to either like draw the section out and split it up into a bunch of simple shapes, and no, we're not doing that.
And not suitable for a 50-minute exam.
Exactly. Is it within your skill set? You've computed centroids before, so I know you can do it. But it's exactly as you put. There's no reason to spend time on that when there's other stuff. Like, if I do that, then we don't have time for, I don't know, a block shear problem or just a design problem, or it doesn't become valuable.
Well, I think we're pretty much cut for good. So.
Well, we got 8 more minutes. I want to see if there's anybody else that's got questions. Because I hope I'm not. I mean, I'm happy to end it now, but I want to make sure that there's no more outlying questions. Don't be don't put yourself in that position where, you know, the class ends and you're like, man, I wish I had asked that. No, ask.
One more question here. On our computational sheets, when we are doing the very long problems, do you want us to reference the tables that we get our information from or not?
That's a good question. I would like you to, but not at the expense of not getting the problems done because you're under the clock.
The reason I'm saying that's like a good sign that we did not cheat, per se. Well, it gives a more better indication that we did not cheat some shape or form.
Well, maybe. I would just not cheat.
Yeah, honestly, like, I think that might be something, if you really want to come back later after you've done the test to write in.
Well,
and then you can turn it in later with the PDF.
Well, let me say this. I don't. The purpose of the additional hour is to give yourself some buffer to get the scan done, get it uploaded, and not be freaked out about time. I would prefer that you not spend that hour working on the exam, because the exam is supposed to be from 11 to noon. Okay. So I'd prefer that you didn't, start changing calcs and updating, designs like, you turned a problem in at noon and you're like, oh, I actually meant to do this, so I'll change it. No, just submit what you finished. Again, I take great pride in being a very fair grader. Okay. That's fine. It's fine. So I'd prefer that you did. Again, like I said, I'm not going to deduct for anybody's grade that if you didn't reference things. Like I'm not going to say you didn't reference this, so you get a 95, whereas this student did, so they get 100. I'm not doing that. I would prefer that you did it, though, just so that you get in the habit of referencing standards when you're doing structural design computations. But again, Mr. Enoch may have some questions about block shear rupture. That's fine. And if there's any global answers that I think the class would benefit from, I'll post that in the Teams channel.
Just a quick one. I think I was right, but so for the one we just had for the block shear, you just since it's on I guess 4 different places, you just calculate it at 1 and then kind of multiply it by 4, and that gives you the correct answer.
Well, that was for that particular connection scenario. So let me pull something up to try and illustrate what I'm talking about, because I'm glad I put these inventor files together, because they're so much better at displaying things than my really poor artwork skills are. Hold on. This is Inventor might take a couple minutes to load. Bear with me. Okay. So this is, all right, hold on. Let me get my little pen here because that'll work a little better. All right. So I have here an image of 3 different potential block shear failure paths. Okay. The reason why we did what you just said on the homework was because it was this particular scenario, right? So what you would do is isolate your computations around a single block. And then because there are 4 blocks, just take the RN for a single block, multiply it by 4 for the entire connection. Then multiply it by your resistance factor phi, and then there you go. You would not do that though here, right? Because here there's just a single block, right? So just compute the block shear capacity of that block, and then that's Rn. Multiply it by phi, and you're good. Same thing here. Multiply that capacity by 0.75, and then you're good. No need to multiply it by 4. All right. So, I mean, this is sort of what I was saying a little bit ago. That like, don't just do what we did on the homework because that's what we did on the homework. Like, if you had a situation like this, a W section connected via the flanges, then that's right. You know, compute the capacity of a single block and multiply it by 4. But not if the scenario changes. Like, address the scenario, not just, you know, regurgitate what we did on the homework. And I'm belaboring that because it's happened a lot on exams. Like, I've seen that happen quite a bit, where you see something new and you're like, oh God, what do I do? Well, I'm just going to do what we did on homework 2.8, you know? And it can lead you astray, because one of the things you'll find about this science is that, you know, if you start doing the math and it starts like not making sense, or the numbers don't quite work out, it can kind of spiral out of control, especially when you get into design sides. Like, if you have computational errors, it can lead to a lot of iterations down the line, and I want to try and avoid that. So, did that make sense? Yeah, if you did that on the homework, then yeah, you probably did it right. All right, any other questions?
I think I calculated all of the failure states on the number by mistake instead of just a block shear.
Well, that's fine. There's nothing wrong with that. Like, if you did gross section yielding and net section fracture, that's fine. I mean, it was just extra practice. I mean, because we had done problems like that before. But one of the things, so let me say this: you probably got an insight then that maybe some of the other students didn't. Which limit state governed?
It was not block shear. I don't remember exactly which one, but it wasn't block shear.
But here's the kicker: it could have been, right? What if the bolts were, I don't know, I don't remember what they were on the homework assignment, but what if instead of 3/4 inch diameter bolts, maybe there were 1 inch diameter bolts? It would have affected things, right? The net section fracture would have changed, the block shear rupture might have changed, and that might have been enough to make one govern versus the other. And the only way that you know what's going to govern is if you just do them, you know? You just have to do them all, because there's so many variables. There's no way of just looking at it and going, net section fracture is going to govern that one, but block shear is going to govern that one. Or if you can, you are better at this than I am.
Yeah, I hear that.
All right. Any other questions? We are hitting the deadline. All right, well, I'm going to go ahead and stop the recording. The solution for the block shear homework should be available here in the next couple of minutes. And if there's any other questions, you know, globally about block shear or anything that comes up in the next couple of days, I will post that in the Teams channel. And with that, best of luck on your exam. And then on Friday, I will post sort of an updated schedule for the semester, because now that we've lost some time, I'm going to wait until the end of the week to where I can sort of figure out where we're at and where we need to go moving forward. But I'll keep you posted and I'll post something on by Friday. That's all I have, everybody. I will see you all on Friday, but best of luck on the exam.